500 years ago, Europe was not the scientific center of the world. That torch burned brightly elsewhere, in a vast and vibrant civilization stretching from Spain to India. This is the story of the medieval Islamic Golden Age and its profound intellectual duel with Christian Europe, a centuries-long exchange of knowledge that built the very foundations of modern science. You will discover how cities like Baghdad and Toledo became engines of innovation, transferring groundbreaking ideas in medicine, math, and astronomy to a Europe on the brink of its own Renaissance. How did a book written in Persia become the standard medical text in Paris for 600 years? What ancient Greek wisdom was saved, translated, and improved upon by scholars in the House of Wisdom before it ever reached a European university? By the end of this journey, your understanding of the so-called Dark Ages will be completely rewritten. What does it truly mean for knowledge to have no borders? The term Islamic Golden Age is more than just a label for a time of peace and prosperity. It describes a civilization-wide project, a deliberate and sustained effort to advance human understanding. For over 500 years, starting in the 8th century, this vast domain became a crucible for ideas. Think of a brilliant mosaic, its pieces gathered from across the known world. Greek philosophy, Persian astronomy, Indian mathematics, and even Chinese technologies were all brought together. But this era was far more than a museum for ancient wisdom. It was a dynamic workshop where these disparate pieces were fitted into a new and breathtaking picture of the universe. The driving force behind this great synthesis was a powerful intellectual principle, a concept known as ijtihad. In essence, this was the spirit of independent reasoning, an encouragement for scholars to question, to experiment, and to think for themselves. This was not a quiet academic exercise. It was a vibrant, often noisy, conversation across cultures and faiths, a conversation actively sponsored by the state itself. The Abbasid Caliphate, especially under the rule of Caliph al-Ma'mun, did not just tolerate this intellectual fervor. They funded it on an imperial scale. The most famous symbol of this commitment was the Beit al-Hikmah, the House of Wisdom in Baghdad. This was not merely a library storing scrolls. It was a powerhouse of thought, a factory for knowledge. Within its walls, teams of translators, copyists, and scholars worked tirelessly, transforming the works of Aristotle, Ptolemy, and Galen from Greek and Syriac into the Arabic language. But they did not simply translate. They scrutinized, they commented, and most importantly, they corrected and expanded upon these ancient texts. This state-sponsored engine of learning created a foundation of shared knowledge so robust that it would eventually support the entire weight of the European Renaissance. Meanwhile, on the other side of the Mediterranean, a different story was unfolding. As the House of Wisdom buzzed with intellectual energy, Western Europe was a patchwork of fledgling kingdoms, still finding its footing after the collapse of Roman authority. This era was far from an empty void, a simple dark age of ignorance. It was a period of profound transformation, where society was slowly rebuilding itself from the ground up. In this fragmented world, the Christian Church emerged as the central pillar of stability. It became the primary, and often the only, institution preserving the fragile flame of literacy. Isolated monasteries nestled in remote valleys and on windswept hills became the new fortresses of knowledge. Within their scriptoriums, monks dedicated their lives to the meticulous, hand-cramping work of copying manuscripts. But their focus was overwhelmingly spiritual. The texts they preserved were Bibles, psalters, and theological commentaries. The vast secular knowledge of the Greeks, the sophisticated mathematics of the Indians, the advanced astronomy of the Persians, these were largely absent from their shelves. The European intellectual horizon was, for a time, intentionally narrow. Yet by the 11th century, the seeds of change were taking root. Political borders began to solidify. Trade routes slowly reopened, and coins once again jingled in market towns. With this newfound stability and economic growth came the rise of cities, places where people and ideas could gather and cross-pollinate. This evolving landscape, hungry for structure and understanding, was about to encounter a treasure trove of knowledge it had never known it was missing. A vast repository of science and philosophy, meticulously cultivated for centuries in the Islamic world, was poised to flood into these eager new centers of European life. The intellectual heart of this vast enterprise beat within a single, legendary institution in Baghdad. The House of Wisdom was the Caliphate's crown jewel, a state-funded project of staggering ambition. Imagine a campus buzzing with the energy of a modern research university, but one where the languages of scholarship were Arabic, Syriac, Persian, and Greek. Here, teams of Christian, Jewish, Muslim, and Sabian scholars did not just coexist, they collaborated with a singular purpose. Their monumental task was to locate, translate, and master the entire known scientific and philosophical legacy of the ancient world. Manuscripts were sought from the furthest reaches of the Byzantine Empire, from the academies of Persia, and from the astronomers of India. But this was never a project of simple preservation, of locking wisdom away in vaults. Every text that entered the House of Wisdom was subjected to intense, critical scrutiny. The scholars there were not passive librarians, they were active pioneers. It was within these walls that the mathematician al-Haytham, synthesizing Greek and Indian knowledge, wrote his revolutionary book on algebra, a term derived from the Arabic al-Jabr in his very title. His work gave us the decimal number system and the foundational principles for solving complex equations. Astronomers at the House of Wisdom, while working within the geocentric model, refined it with such painstaking observation and mathematical precision that their star catalogues and planetary tables remained the most accurate in the world for centuries. This was not a quiet library, but a dynamic factory for new knowledge, a testament to what happens when a civilization decides to make the organized, collaborative pursuit of understanding its highest priority. The foundational corpus created here would become the indispensable textbooks for a continent just beginning to stir from its long intellectual slumber. A different kind of intellectual conquest was unfolding in the Spanish city of Toledo. After its capture by Christian forces in 1085, the city did not shed its multicultural past. Instead, it became a bridge. The great libraries of Toledo, filled with thousands of Arabic manuscripts, stood intact. These shelves held a treasure greater than any gold, a vast archive of knowledge that Europe had lost, forgotten, or had never even known. The city swiftly transformed into the world's most important translation workshop, a place where the primary mission was not to generate new ideas, but to perform the vital work of transfer. This was the crucial next step. The knowledge synthesized in Baghdad now needed a gateway into the Latin-speaking world, and Toledo became that open door. Here, in a remarkable collaboration, teams of Jewish, Christian, and Muslim scholars gathered. A Mozarabic Christian might read the Arabic text aloud, a Jew would translate it into the shared vernacular of Spanish, and a Latin scholar would then render it into the formal language of the Church and the emerging universities. This was not a quiet, solitary endeavor. It was a bustling, polyglot conversation, a noisy marketplace of ideas where the currency was words and the profit was understanding. At the heart of this effort were dedicated figures like Gerard of Cremona, an Italian scholar who traveled to Toledo specifically in search of a text he could not find anywhere in Europe. He stayed for decades, ultimately translating over 70 works from Arabic into Latin. Through his tireless labor and that of his colleagues, Europe was introduced to the monumental medical encyclopedia of Avicenna, a text that would become the standard for centuries. They translated the profound philosophical commentaries of Averroes, which reintroduced a purified Aristotle to the West. They brought over the detailed chemical and medical works of al-Razi. This was not a trickle of information, it was a flash flood. The pipeline from Toledo fundamentally rewired the European mind, delivering the very intellectual tools that would be used to build the Renaissance. This linguistic bridge was built on a single, powerful foundation, the Arabic language. From the bustling markets of Cordoba to the distant observatories of Samarkand, Arabic was the universal tongue of science, a scholarly dialect that united a vast and diverse civilization. It functioned much like Latin did in the monasteries of Europe, but with a crucial difference. When the translation movement began in Baghdad, Arabic was a relatively young language of scholarship. It had to be built almost from the ground up into a precise instrument for conveying complex ideas. Teams of scholars did not merely translate Greek philosophy or Indian mathematics word for word. They engaged in a creative act of linguistic engineering, coining new terms, adapting existing words, and constructing a complete scientific vocabulary. Words like algebra, algorithm, and alkali are all Arabic in origin, permanent echoes of this lexical revolution. This created a common toolkit of concepts, allowing a physician in Cairo and an astronomer in Persia to read the same text and debate its finer points with perfect mutual understanding. In Europe, Latin was the established language of the Church and of law, but it was a lexicon of faith and authority, not of empirical inquiry. It lacked the words to describe the movement of planets according to geometric models, or the chemical reactions in a laboratory alembic. So when Gerard of Cremona and his colleagues in Toledo opened an Arabic manuscript, they faced a monumental challenge. They were not just translating from one language to another, they were translating from a complete scientific culture into one that was missing its most fundamental parts. They had to first grasp the sophisticated Arabic concept, and then invent a new Latin word or phrase to capture its meaning. This was the true birth of European scientific terminology, a painstaking process of forging a new language of discovery. Without this dual act of comprehension and creation, the profound ideas flowing from the Islamic world would have remained silent, locked in a code that Europe could not decipher. While scholars in Toledo were translating texts, their Islamic counterparts were gazing upward, mapping the heavens with revolutionary precision. Astronomy was not a mere academic pursuit in the Islamic world. It was a science of profound practical and spiritual importance. Determining the exact times for daily prayers, establishing the direction of Mecca from any location on Earth, and accurately predicting the cycles of the lunar calendar all demanded a detailed understanding of the cosmos. This practical need, backed by the immense resources of the state, fueled an astronomical revolution. Caliphs sponsored the construction of colossal observatories, vast complexes filled with giant quadrants and armillary spheres designed to measure the angles of stars and planets with unprecedented accuracy. In these institutions, astronomers did not simply accept the ancient Greek models handed down to them. They tested them and they found them wanting. The great al-Battani, working from his observatory in Syria, meticulously calculated the length of the solar year to within minutes of its true value. He precisely documented the slow, wobbling drift of the Earth's axis, a phenomenon known as the precession of the equinoxes. His tables of planetary motion were so accurate they remained in use for centuries. Later, in the very city of Toledo that would become a translation hub, the brilliant al-Zarqali designed an advanced version of the astrolabe, a portable computer of the stars that could solve hundreds of astronomical problems. He also compiled the Toledo tables, a set of data that allowed anyone to predict the future positions of the sun, moon, and planets. When these works were translated into Latin, they sent shockwaves through the nascent universities of Europe. For the first time, European scholars had access to observational data that was not ancient speculation but current, tested, and stunningly precise. This Islamic legacy of empirical observation and mathematical rigor provided the essential raw material for a new cosmic understanding. The revolutionary model proposed by Copernicus centuries later did not emerge from a vacuum. It was built directly upon this foundation of painstakingly collected data that proved the old models were broken and that a new, bolder vision of the universe was not just possible but necessary. While astronomers charted the cosmos, physicians were mapping the intricate terrain of the human body with the same empirical rigor. The hospitals of Baghdad and Cairo were not mere hospices for the dying. They were vibrant centers of healing, diagnosis, and medical education. At the forefront stood al-Razi, a master clinician whose methods feel startlingly modern. He was the first to provide clear, detailed descriptions that allowed doctors to accurately differentiate between smallpox and measles, a crucial diagnostic leap that saved countless lives. He wrote extensively on pediatrics and even on the psychological well-being of his patients. But the single most influential medical text to emerge from this era was the Canon of Medicine, authored by the polymath Ibn Sina, known in the West as Avicenna. This was not just a book, it was a monumental 5-volume synthesis of all known medical knowledge, from Greek humoral theory to his own meticulous clinical observations. The canon systematically introduced concepts that would become pillars of modern medicine. It described the contagious nature of tuberculosis, advocated for the use of quarantine to control the spread of epidemic diseases, and even outlined principles for testing new drugs that resemble our modern clinical trials. When this colossal work was translated into Latin in the 12th century, its impact was immediate and overwhelming. It rendered all earlier European medical texts obsolete. The canon became the undisputed authority, the core textbook for centuries at the great university medical schools of Montpellier and Bologna. A young medical student in Paris or Padua would have learned his entire craft from this Arabic text, internalizing a system of medicine that valued systematic diagnosis, evidence-based treatment, and a comprehensive view of the patient. The very structure of the modern hospital, with its wards, its teaching functions, and its focus on clinical evidence, owes a profound debt to the models perfected in the Islamic world. This was not a simple transfer of facts, it was the transplantation of an entire medical philosophy, one that would nurture the seeds of modern science for generations to come. The patient's chart and the astronomer's star table both relied on a single, revolutionary innovation, a new language of numbers. Before this transformation, Europe was trapped in a numerical dark age, trying to build a modern economy with the mathematical equivalent of stone tools. The Roman numeral system, with its clunky symbols and lack of a zero, made even basic arithmetic a torturous ordeal. Multiplying 847 by 69 was a task that could consume an entire afternoon for a skilled clerk. This was the immense practical barrier that the Islamic world shattered. The key was a numerical system originating in India, but it was the scholars of the Islamic Golden Age who perfected it, tested its limits, and ultimately delivered it to the West. At the forefront of this revolution was the mathematician al-Haytham. In his monumental book, the compendious book on calculation by completion and balancing, he did far more than just introduce new numerals. He laid down the foundational rules of a new mathematical discipline, one he called algebra. We know it today as algebra. This was not just about finding an unknown number, it was a powerful new way of thinking. Algebra, meaning restoration or completion, provided a systematic method for solving complex equations, for bringing balance to both sides of an equal sign. It gave mathematicians a tool to model real-world problems, from dividing inheritances according to Islamic law to calculating the volumes of complex geometric shapes for architecture. His name itself became immortalized. When his works were translated into Latin, his name was rendered as algorithmy, giving us our modern term algorithm, a step-by-step procedure for solving a problem. The adoption of this new system was not immediate or easy in Europe. Many merchants distrusted these strange new symbols from the East, viewing them as a form of sorcery or fraud. But the sheer power of decimal calculation was undeniable. How could you track the compounding interest on a loan or calculate the precise trajectory of a cannonball without a zero and a place value system? This was the ultimate gift, a set of intellectual keys that unlocked new possibilities in commerce, engineering, and theoretical science, setting the stage for everything from double-entry bookkeeping to the calculus of Newton and Leibniz. But this exchange of knowledge was not limited to maps of the stars or equations on a page. It reached into the deepest questions of human existence, sparking a revolution in thought itself. A profound intellectual struggle echoed across both the Islamic world and Christian Europe, a centuries-long debate over the relationship between divine revelation and human reason. At the heart of this conflict was the philosophy of Aristotle, a system of logic and natural science so powerful it threatened to overwhelm traditional theological frameworks. In the Islamic world, brilliant minds like al-Farabi and Ibn Rushd, known in the West as Averroes, took up this challenge directly. They argued passionately that philosophy and religion were not enemies, but two different paths leading to the same ultimate truth. For them, reason was a divine gift, a tool for understanding the intricate laws of God's creation. Averroes, in particular, produced meticulous commentaries that purified the works of Aristotle from later editions, presenting a clear, rational vision of the universe. When these Arabic commentaries were translated into Latin in places like Toledo, they hit the emerging universities of Paris and Oxford with the force of an intellectual earthquake. For the first time, European scholars encountered a fully formed system of thought that was logically rigorous, comprehensive, and completely independent of the Bible. This ignited furious debates known as the conflict over Arabo-Aristotelian thought. Conservative theologians saw a dire threat, fearing that reason would displace faith. But others saw an unprecedented opportunity. Among them was the Dominican friar Thomas Aquinas. He embarked on a monumental project to build a bridge to synthesize Aristotelian logic with Christian doctrine. And the blueprint for that bridge came directly from the Islamic philosophers. Aquinas did not simply borrow a few ideas. He adopted the entire framework developed by Averroes and others, using their methods to argue that reason and faith were compatible spheres of knowledge. His great synthesis, which became the foundation of Catholic theology for centuries, was a direct continuation of a conversation that began in the lecture halls of Cordoba and Baghdad. This was not a story of one culture simply giving and another receiving. It was a shared transnational quest for harmony, proving that the most profound truths often emerge from the collision of different worlds. That same spirit of rational inquiry was not confined to the heavens or the human body. it also bubbled and steamed in the glass vessels of the laboratory. The quest to transform base metals into gold, a pursuit we now dismiss as alchemy, was far more than a search for mythical riches in the Islamic world. It represented a radical commitment to hands-on experimentation, a philosophy championed by the father of chemistry himself, Jabir ibn Hayyan. Jabir, known in Europe as Geber, insisted that true knowledge of nature could not come from books and speculation alone. It had to be proven through direct, repeatable action in the workshop. He transformed the laboratory from a place of mystical secrecy into a theater of systematic process. There, he designed and perfected the fundamental tools that would become the backbone of chemical science for 1,000 years. He invented the alembic, a sophisticated apparatus for distillation that could separate liquids based on their boiling points. He mastered the techniques of filtration to purify substances and crystallization to form pure, geometric solids from solutions. Jabir did not just use these tools, he classified the very substances he worked with, dividing them into new categories like spirits, metals, and stones, laying the groundwork for our modern understanding of elements and compounds. When his extensive writings were translated into Latin, they delivered a shock of practical energy to European scholars. They were not just reading about abstract theories, they were being handed a detailed manual for doing. The clear instructions for building an alembic and the insistence that an experiment must be reproducible to be valid, this was the true alchemical gold. This methodological shift from passive contemplation to active, evidence-based testing was a revolutionary intellectual gift. It provided a crucial piece of the puzzle, helping to forge the very mindset that would one day evolve into the disciplined procedure of the modern scientific method. The laboratory's focus on direct experimentation found its ultimate expression in the study of light itself. A single, brilliant mind in Cairo would dismantle a 2,000-year-old idea about how we see the world. The polymath Ibn al-Haytham, known in Europe as al-Haytham, confronted a fundamental question. Do our eyes emit some kind of energy to see, or do they receive something from the world? The ancient Greeks, from Plato to Euclid, had championed the emission theory. They believed vision worked because our eyes sent out invisible rays to touch the objects we look at. But Ibn al-Haytham saw a fatal flaw in this logic. If our eyes sent out light, he reasoned, why can we not see in the dark? Why does staring at a distant star not make it appear any closer? His skepticism was not born from mere philosophical debate. It was driven by a profound commitment to a new standard of proof, a standard we now call the scientific method. He declared that a claim must be supported by experimental evidence and must align with mathematical reasoning. To test the nature of vision, he created a simple yet revolutionary apparatus. He entered a completely darkened room, allowing only a single pinpoint of light to enter through a tiny hole in one wall. What he observed on the opposite wall would change science forever. There, upside down and shimmering, was an image of the world outside. This was the camera obscura in action, and it provided irrefutable evidence. The image was formed by rays of light traveling in straight lines from external objects through the small aperture and projecting onto the inner wall. Our eyes, he concluded, do not send out rays. They are passive receptors, carefully designed lenses that collect the light rays bouncing off everything around us. This was a complete inversion of human understanding. His monumental book of optics did not stop there. He meticulously studied reflection, detailing the exact angles at which light bounces off mirrors. He explored refraction, describing how light bends when it passes from air into water or glass, laying the groundwork for the invention of lenses. He even questioned the nature of light itself, proposing that it travels at a finite, though immense, speed. When his work finally reached Europe, translated into Latin, its impact was immediate and profound. It became the essential textbook for thinkers like Roger Bacon, who used its principles to design the first reading glasses, and Johannes Kepler, who relied on al-Haytham's model of the eye to correctly explain how the human retina functions. Ibn al-Haytham's greatest legacy was not a single discovery but a powerful new way of knowing. He demonstrated that truth is not revealed by authority, whether ancient or modern. It is uncovered through a disciplined dialogue with nature, a conversation built on doubt, experiment, and mathematical proof. This methodological shift would become the bedrock of all modern science, a tool that Europe was only just beginning to master. This same empirical drive that charted the paths of light also mapped the very contours of the Earth itself. While philosophers debated the cosmos, a more practical science was flourishing, one born from the immense needs of a sprawling civilization. Successful trade across thousands of miles, the annual pilgrimage to Mecca required of every able Muslim, and the efficient administration of a vast empire all demanded an exact knowledge of the world. Islamic geographers did not simply rely on ancient texts. They became voracious collectors of data, sending out inquiries and interviewing merchants, pilgrims, and travelers returning from the farthest reaches of Africa and Asia. They synthesized these countless first-hand accounts with their own astronomical observations, creating a dynamic and ever-improving picture of the planet. The most stunning achievement of this geographical project was born in an unlikely place, the court of a Christian king in Sicily. There, the Muslim scholar al-Idrisi served King Roger Roman II, a Norman ruler with a profound thirst for knowledge. For 15 years, al-Idrisi directed a team of researchers and draftsmen, combining Arab geographical knowledge with new information gathered by Norman sailors and explorers. The result was the Tabula Rogeriana, a monumental world map and accompanying book that represented the absolute pinnacle of medieval cartography. This was not a fanciful drawing filled with monsters. It depicted the Earth as a sphere, clearly showing the sources of the Nile, the sweep of the African coast, and the detailed contours of Asia, lands that were mere blank spaces on European maps of the era. It was, for its time, breathtakingly accurate. These maps and the navigational techniques that accompanied them, like the refined astrolabe used for finding latitude at sea, did more than guide travelers within the Islamic world. They became a secret weapon for a continent on the cusp of its own great adventure. When the European age of exploration began, the Portuguese and Spanish navigators who set out into the Atlantic were not sailing blindly into the void. They were armed with cartographic knowledge, concepts of a spherical world, and navigational tools that were the direct legacy of this Islamic geographical tradition. The very routes that carried Vasco da Gama to India and Columbus across the ocean were charted, in part, with maps drawn centuries earlier in a spirit of global inquiry. Sicily's sun-drenched shores became a second great gateway for knowledge. While Toledo was a center of translation, the Norman court in Palermo was a living laboratory of cultural fusion. Here, Christian kings ruled a population that was largely Arabic-speaking, Greek Orthodox, and Jewish. This was not a conquered land trying to reclaim its past, but a vibrant, hybrid society actively building a shared future. The Norman rulers, particularly the brilliant and curious King Roger II, did not see Arabic culture as something to be suppressed. They embraced it as the key to modern statecraft and sophisticated living. Roger himself spoke and read Arabic fluently. He surrounded himself with Muslim scholars, poets, and scientists, creating an environment where intellectual curiosity trumped religious boundaries. His court became a magnet for thinkers from across the Mediterranean, all drawn by a ruler who valued knowledge for its power to enlighten and to govern. This was not a passive tolerance but an active, royal sponsorship of exchange. Under his patronage, teams of scholars worked to translate crucial Arabic texts on geography, astronomy, and medicine directly into Latin. The most famous product of this collaboration was the magnificent world map, the Tabula Rogeriana, crafted by the Muslim geographer al-Idrisi. For 15 years, al-Idrisi and the king's scholars pooled Arab geographical data with reports from Norman sailors, producing a vision of the world far more accurate than any other in Christendom. But the transmission did not stop with maps. It extended to the very mechanics of government. The Sicilian court adopted the sophisticated Arabic systems of administration, their advanced accounting methods, and even their architectural innovations, blending them with Norman and Byzantine traditions to create a uniquely efficient state. This was knowledge transfer in its most practical form. Later, the even more controversial Emperor Frederick II, raised in this very environment, would continue this legacy with a passion that shocked his European peers. He corresponded directly with Arab philosophers on scientific questions, and his own monumental book on falconry was deeply indebted to Arabic sources on zoology and veterinary science. The Sicilian Channel proved that the flow of ideas was not a one-way street from east to west. It was a dynamic conversation happening in real time, in a kingdom where the ruler himself was a fluent participant in both worlds. This alternative route, flowing through the heart of the Mediterranean, ensured that the European revival was nourished by multiple streams of wisdom, each one deepening the intellectual soil from which the Renaissance would eventually bloom. This explosion of new knowledge demanded a new kind of home. The isolated monastery and the royal court could no longer contain the flood of texts and ideas arriving from Toledo and Sicily. Europe needed an institution built for scale, for debate, and for the systematic training of the mind. The answer emerged in the form of the university, a revolutionary concept that would become the engine of European intellectual life for centuries to come. In cities like Bologna and Paris, these new corporations of scholars and students began to take shape. At Bologna, the focus was on the practical science of law, dissecting Roman legal codes with a new logical rigor. In Paris, the great debate swirled around theology and philosophy, fueled by the very Arabic translations of Aristotle that had so recently arrived. The backbone of this new education was the traditional 7 liberal arts, the trivium and quadrivium, but this old framework was now injected with powerful new content. The quadrivium, which covered arithmetic, geometry, astronomy, and music, was utterly transformed. A student was no longer just studying the abstract geometry of Euclid. He was now grappling with the advanced trigonometry of al-Battani and the revolutionary algebra of al-Khwarizmi. In the medical faculty, the curriculum was dominated by a single, monumental text, the Canon of Medicine by Ibn Sina. For a young scholar, a medical degree was in essence a deep and critical study of this Arabic masterpiece. The university provided the stable, structured environment where this recovered knowledge could be put to the test. The core of academic life was the formal disputation, a rigorous public debate where students and masters would argue opposing sides of a complex question, citing authorities from the Bible to Avicenna to Averroes. This was not passive learning, it was intellectual combat, training a generation to think critically, to defend their ideas with logic, and to challenge even the most revered sources. This corporate identity, with its defined degrees and protected privileges, created a pan-European community of scholars who spoke the common language of Latin and shared a common foundation of texts. The university did not merely store the knowledge that came from the Islamic world. It activated it, turning ancient wisdom and Eastern innovation into the fuel for a uniquely European Renaissance. Yet this flood of new ideas did not wash smoothly over the European mind. It crashed against a formidable wall of established belief. the arrival of Aristotelian science, filtered through the brilliant commentaries of thinkers like Averroes, was not a quiet gift. To many guardians of Christian orthodoxy, it sounded like a declaration of war. Here were philosophical propositions, articulated with impeccable logic, that directly challenged the core of revealed truth. The concept of a world that was eternal, with no moment of divine creation, contradicted the book of Genesis. The theory of a single, universal intellect shared by all humanity seemed to deny the Christian belief in an individual, immortal soul. These were not minor quibbles. They struck at the very heart of Christian doctrine, and the reaction from church authorities was swift and severe. In the 1270s, the Bishop of Paris issued a formal condemnation, banning the teaching of over 200 Aristotelian and Arabo-Aristotelian theses at the university. The very books that had ignited the European intellect were now being publicly burned. This was a moment of profound crisis. Would Europe retreat from this challenging new knowledge, or would it find a way to make the foreign wisdom its own? The tension between the lecture hall and the cathedral had never been greater, but conflict, as it so often does, became the catalyst for an even greater intellectual synthesis. Out of this turmoil emerged two remarkable minds, Albertus Magnus and his most famous student, Thomas Aquinas. They refused to see reason as an enemy of faith. Instead, they embarked on an ambitious project to build a bridge between the two, to create a grand harmony. Their strategy was as brilliant as it was daring. They did not simply reject the powerful logic of Aristotle and his Islamic interpreters. They embraced it. Aquinas, in his monumental Summa Theologica, argued that God was the author of two books, the book of Scripture and the book of nature. Since the same God wrote both, he reasoned, they could not ultimately contradict one another. If human reason, guided by Aristotelian philosophy, led to a conclusion about the natural world that seemed to conflict with the Bible, then the problem was not with reason, but with a flawed interpretation of the sacred text. He took the very framework developed by Averroes, the method of using logic to understand a rational universe, and he turned it into a powerful defense of Christian theology. In his hands, Aristotelian proofs for a prime mover became arguments for the existence of the Christian God. This was not a surrender of faith to philosophy. It was a conscious, creative act of integration. The foreign knowledge, once viewed as a dangerous threat, was carefully translated, debated, and ultimately woven into the very fabric of Western thought. The condemned ideas of yesterday became the foundational textbooks of tomorrow, proving that the most enduring knowledge is not merely received, but actively remade. His philosophical system was a grand cathedral of thought, built to house every mystery of the universe under one roof. The man we know as Avicenna, born Ibn Sina in 10th century Persia, was a phenomenon of intellectual energy. By the age of 18, he had mastered all known fields of medicine, law, and philosophy. He wrote while on the run from political turmoil, composing his vast encyclopedias in hiding, often from memory. His output was staggering, nearly 450 works spanning medicine, astronomy, mathematics, music, and the deepest questions of metaphysics. But two books in particular would become pillars of the Western mind. The first was his Canon of Medicine, a 5-volume masterpiece that organized all known medical knowledge into a single, logical system. It was so comprehensive and so brilliantly structured that it became the undisputed medical textbook in Europe for over 600 years. But his other great work, the Book of Healing, was even more ambitious. This was not a book about curing the body, but about healing the soul through knowledge. It was a philosophical summa, a vast synthesis that wove together the logic of Aristotle with the mystical emanation theories of Neoplatonism. Avicenna proposed a complete model of reality, from the celestial intelligences that govern the spheres down to the human soul and its connection to the divine. He asked questions that would echo for centuries. How does the mind abstract universal concepts from the particular objects we see? What is the nature of the soul, and can we prove its existence independently of the body? His answers were built on a powerful tool, the logical syllogism. He demonstrated that you could apply the same rigorous, step-by-step reasoning used in geometry to prove the existence of God or the immortality of the soul. When these works reached Europe, they created a school of thought. Latin scholars who called themselves the Avicennians saw in his writing a complete philosophical package, a ready-made system that could explain everything. They embraced his method of using logical demonstration to explore the deepest metaphysical truths. This approach, championed by figures like Thomas Aquinas, did not merely borrow a few ideas from Avicenna. It adopted his entire framework for reconciling faith and reason, proving that the divine could be understood through the rational order of creation. Avicenna's legacy shows us that knowledge transfer is not just about facts and figures. It is about importing entire architectures of thought, intellectual blueprints so powerful that they can shape the very foundations of another civilization's worldview. While Avicenna offered a complete philosophical system, another thinker would force Europe to confront an even more radical challenge. In the vibrant intellectual landscape of Islamic Spain, Ibn Rushd, known to the West as Averroes, dedicated his life to a singular mission. He believed the original works of Aristotle had been obscured by centuries of Neoplatonic commentary, and he set out to restore the pure, rigorous logic of the Greek master. His meticulous line-by-line commentaries did not simply explain Aristotle, they purified him, creating a clear, rational vision of the universe that operated entirely by its own discoverable laws. This project led him to a bold and controversial conclusion. He argued that philosophical truth, arrived at through reason and logic, and religious truth, revealed through scripture, were two distinct but equally valid paths leading to the same ultimate reality. This concept, often simplified as the theory of double truth, was explosive. It suggested that something could be philosophically true, like the eternity of the world, even if it appeared to contradict a literal reading of a sacred text. In the lecture halls of the University of Paris, this idea ignited an intellectual firestorm. A group of radical scholars, the Latin Averroists, embraced Ibn Rushd's rationalism with fervent passion. They taught his commentaries as the definitive interpretation of Aristotle, even when his conclusions directly challenged core Christian doctrines. The clash was inevitable. How could the world be both created and eternal? How could individual souls be both immortal and part of a single universal intellect? This was not a polite academic debate. It was a fundamental collision between the new tools of reason and the ancient authority of faith, a confrontation that threatened to tear the university apart. Yet this very conflict became the catalyst for an unprecedented intellectual leap. The sheer power of Averroes' logic forced the best minds in Europe to build a stronger, more sophisticated defense of their own beliefs. They could not simply dismiss his arguments, they had to engage with them, dissect them, and ultimately transcend them. The intense European engagement with this foreign philosopher did not destroy Christian theology. Instead, it compelled it to mature, to incorporate logical rigor, and to articulate its doctrines with a new level of philosophical depth. The awakening sparked by Ibn Rushd proved that the most dangerous ideas are often the most vital, for they are the ones that force a civilization to grow. This great collision of ideas demanded a master architect. As the condemned books smoldered in Paris, a quiet Dominican friar was already at work, building not a fortress to defend against the new philosophy, but a vast cathedral to house it. Thomas Aquinas confronted the central crisis of his age head-on. He saw the undeniable power of Aristotelian logic, sharpened by the commentaries of Averroes and the metaphysical system of Avicenna, and he recognized that the old ways of thinking could no longer withstand its force. The only path forward was not to reject this foreign wisdom, but to absorb it completely and make it the new foundation. His monumental Summa Theologica was that new foundation, a work of breathtaking ambition that sought to answer every possible question about God, humanity, and the natural world. Its method was its revolution. Aquinas did not simply quote scripture. He structured his arguments like a geometric proof, using the very logical tools he had learned from the Arabic philosophers. He would pose a difficult question, present objections drawn from authorities like Averroes that seemed to contradict Christian belief, and then, with painstaking clarity, he would build his response. He used Aristotelian concepts of causality to construct new, powerful proofs for the existence of God, arguing from the motion and design we see in the world back to a prime mover and a divine intelligence. Where Averroes spoke of a single universal intellect, Aquinas argued for individual, immortal souls, using the same logical framework to reach a different conclusion. This was the great synthesis in action. He declared that God was the author of two books, the book of Scripture and the book of nature. Since both came from the same source, they could never truly be in conflict. If human reason, guided by Aristotle's physics, led to a conclusion about the natural world, then it was a truth to be embraced, not feared. A misunderstanding of the Bible, he suggested, should not stand in the way of a scientific fact. With this single, brilliant move, Aquinas legitimized the entire scientific enterprise within a Christian context. The pursuit of knowledge about the physical world was no longer a dangerous distraction from salvation. It was a form of devotion, a way to read the mind of God by studying His creation. The work of Thomas Aquinas represents the final, mature fruit of the centuries-long translation movement. It was not merely about storing Arabic knowledge in European libraries. It was about digestion, transformation, and the creation of something entirely new. The foreign tools of reason were no longer foreign. They had become the essential instruments for building the modern Western mind. The profound ideas debated in university halls required a physical world capable of supporting them. This intellectual awakening was built on a foundation of tangible, everyday technology, much of it imported from the Islamic world and adapted to European needs. Consider the simple act of turning a page in a book. For centuries, European manuscripts were painstakingly written on parchment, a material made from scraped and treated animal skins. A single Bible might require the skins of more than 200 sheep, making books luxuries only monasteries and kings could afford. This all changed with the arrival of papermaking, a technology that traveled from China through the Islamic world into Spain and Sicily. Islamic artisans perfected the process, using linen and hemp rags to create a durable, affordable writing surface. Suddenly, the cost of producing a book plummeted. Knowledge was no longer locked in a vault of precious parchment. It could be copied and spread with unprecedented speed. This was the Gutenberg revolution before the printing press, a quiet transformation in the very medium of thought that made the widespread literacy of the Renaissance possible. Out in the sun-baked fields of Spain and Sicily, another quiet revolution was turning arid land into lush gardens. Islamic hydraulic engineering was centuries ahead of anything in Europe. Engineers designed and built sophisticated networks of water wheels, known as norias, and complex irrigation canals that could lift water from rivers and distribute it across vast distances. These were not crude devices, they were masterpieces of mechanical engineering, often powered by the flow of the river itself. In places like Valencia, these inherited irrigation systems transformed agriculture, allowing for the cultivation of new, water-intensive crops. And with the water came the crops themselves. Oranges, lemons, apricots, spinach, and artichokes, all introduced to Europe through Al-Andalus, began to appear on dinner tables. New farming techniques like crop rotation and soil science boosted yields and improved nutrition, supporting larger, healthier populations in growing cities. The food that fueled the thinkers and artists of the Renaissance was in many ways a gift from this technological exchange. Even the quest for health and comfort was transformed in the workshop. The Islamic mastery of distillation, a process perfected in the laboratories of Jabir ibn Hayyan, gave Europe new tools for medicine and daily life. The alembic, that iconic vessel with its cooling tube, allowed alchemists and apothecaries to isolate the essential spirits of substances. They could now produce pure, potent alcohols. These were not initially for drinking, but were hailed as miraculous medicines, the aqua vitae or water of life, used as antiseptics and solvents for new herbal remedies. The same process was used to capture the delicate essences of roses and oranges, creating perfumes and scented waters that introduced a new dimension of personal luxury to European society. From the books they read and the food they ate to the medicines they relied on, the material life of ordinary Europeans was quietly but profoundly upgraded. This was the real, ground-level impact of the knowledge transfer, a technological osmosis that built a richer, more capable, and better-informed world, creating the very conditions that would allow a dormant continent to reawaken. This shared vocabulary of ideas found its most breathtaking expression in stone, glass, and pigment. The cultural exchange between the Islamic world and Europe was not confined to the pages of books. It was carved into the very walls of their cities and illuminated in their most sacred texts. Walk into any great Gothic cathedral and look upward. Soaring above you are the pointed arches that define the style, creating that sensation of breathtaking verticality. This revolutionary architectural form did not emerge from a vacuum in 12th century France. Its origins can be traced directly to the structures of the Islamic world, to palaces and mosques where pointed arches had been used for centuries to create larger, more stable openings. Crusaders, pilgrims, and merchants encountered these designs in the Near East and brought the concept home, where European master builders adapted and perfected it, using it to build taller naves and fill the walls with vast, glorious stained glass. The geometry did not stop with the arches. Intricate interlacing patterns, known as arabesques, began to appear in the margins of European manuscripts and in the stonework of church cloisters. These endless, non-figurative designs, which symbolized the infinite nature of creation in Islamic art, were adopted by Christian artists who saw in their mathematical perfection a reflection of God's orderly universe. Nowhere is this fusion more stunning than in Spain under a style known as mudejar. Here, Muslim artisans living under Christian rule continued to practice their craft. For their new patrons, they created palaces that were breathtaking hybrids. The Alcazar of Seville, built for a Christian king, is a masterpiece of this synthesis. Its courtyards feature delicate horseshoe arches. Its ceilings are a complex forest of carved, gilded wood, forming star-shaped patterns that seem to dissolve into the heavens. Biblical scenes might be framed by Kufic script, the elegant Arabic calligraphy now used as pure decoration. This was not mere imitation. It was a genuine collaboration, a deep aesthetic conversation where Christian kings actively desired the beauty and sophistication that Islamic artistry represented. A prince in his mudejar palace, a monk illuminating a Bible with arabesque borders, a master mason raising a Gothic vault, all were participating in a shared visual language, proving that the most profound exchanges are not just read but lived and experienced. Yet every golden age casts a long shadow. By the 13th century, the brilliant constellation of Islamic learning began to dim, its lights flickering out one by one. The unity of the Abbasid Caliphate shattered into a mosaic of rival states, each draining resources into endless military campaigns instead of funding grand observatories or translation houses. This political fragmentation was devastating, but it was the arrival of a storm from the east that delivered the final, crushing blow. In 1258, the Mongol armies of Hulagu Khan laid siege to Baghdad. The city that had once been the capital of world thought was brutally sacked. Its libraries were thrown into the Tigris River, the ink from countless manuscripts said to have turned the waters black for days. The House of Wisdom was utterly destroyed. With its central nervous system severed, the vast intellectual network began to falter. At the same time, a profound philosophical conversation that had once buzzed with open inquiry began to turn inward. The spirit of Ijtihad, that fearless independent reasoning, was increasingly challenged by more conservative theological currents that viewed the wholesale adoption of Greek philosophy with deep suspicion. The great rationalist project of scholars like Averroes was marginalized, and the doors of innovative interpretation, once thrown wide open, were slowly, quietly closed. While the Islamic world confronted this cascade of crises, Europe was undergoing the opposite transformation. The seeds imported from Toledo and Palermo had not just taken root, they were flourishing into a forest of new institutions. The knowledge that had been a foreign import was now a native possession, debated in universities, refined by scholars, and fueling a new confidence. The pupil was rapidly becoming a peer and soon a rival. This was the great pivot point, a historic reversal of intellectual momentum. The very success of the centuries-long knowledge transfer had equipped Europe with the tools to eventually surpass its teachers, setting the stage for a new scientific revolution that would reshape the world. The idea of an eternal war between East and West shatters against the simple, stubborn facts of history. This was never a story of two monolithic blocks shouting across a void. It was a bustling, messy, and deeply human marketplace of the mind. A Christian monk in a Spanish monastery might eagerly await a translation of an Arabic medical text, copied by a Jewish scribe who had learned his craft from a Muslim teacher. A Norman king in Sicily proudly wore robes of silk inscribed with Cufic script, the elegant Arabic lettering becoming a symbol of his own sophisticated power. These were not anomalies, they were the very engine of progress. The Renaissance was not a purely European miracle. It was the final, magnificent harvest from seeds that had been planted and cultivated in fields across the Mediterranean world. This legacy of shared learning forces us to confront a profound and urgent truth. Our modern world, with its complex challenges from climate science to public health, does not need more walls. It needs more bridges, more translators, and more of the collaborative spirit that once turned cities like Toledo and Palermo into beacons of human achievement. The past offers us a powerful blueprint not for conflict but for conversation. While rationalists were building bridges of logic, another kind of seeker was mapping the hidden pathways of the heart. Far from the noisy university disputations and the bustling royal courts, a quieter but equally profound exchange was unfolding in the domain of mystical experience. Across the Islamic world, Sufi orders were cultivating a spiritual philosophy centered on divine love and the soul's direct, intimate journey toward God. This was not about memorizing legal texts or debating theological fine points. It was about a personal, transformative encounter with the divine, a longing to dissolve the self into the infinite ocean of God's presence. In Spain, the great master Ibn Arabi penned vast poetic works exploring the very nature of reality. He spoke of the unity of existence, a vision where all of creation is a manifestation of the divine names and attributes. For Ibn Arabi, the entire cosmos was a mirror reflecting the face of God, and the human soul's ultimate purpose was to polish that mirror until it could perceive nothing else. His concept of the perfect human was one who had become a clear channel for divine grace, a complete reflection of God's beauty in the world. At almost the exact same time, in the Rhineland forests of Germany, a Dominican friar named Meister Eckhart was preaching sermons that shook the foundations of conventional piety. He spoke of a Godhead beyond even the concept of God, an ineffable ground of being from which all things flow. He urged his listeners to detach from all created things, to become a pure nothing, so that God could be born in the soul. This was not the distant God of the philosophers, but an intimate presence to be experienced directly. The parallels are breathtaking. Both mystics describe the soul's journey as a return to its origin. Both used the powerful metaphor of a spark of the divine trapped within the human being, yearning to return to its source. Both championed an inward path that often bypassed institutional authority in favor of personal revelation. While it is difficult to prove a direct line of transmission, these shared themes are too powerful to be mere coincidence. They point to a universal human longing, a spiritual current that flowed beneath the surface of official doctrines, connecting hearts and minds across the artificial borders of faith. This was the other great conversation, one that enriched the inner lives of millions, offering a vision of unity in an age too often defined by division. That legacy is not confined to history books. It lives in the very tools we use to understand our universe. The scientific method, the disciplined process of hypothesis and experiment that drives modern research, was profoundly shaped by the work of Ibn al-Haytham. His insistence that a claim must be tested through repeatable, verifiable evidence established a new standard for truth, one that moved beyond ancient authority and into the realm of demonstrable fact. Every clinical trial testing a new medicine, every physics experiment at CERN, follows in the footsteps of that simple, darkened room where light was first understood. Our mathematical language is also a direct inheritance. Try to balance your checkbook using Roman numerals. The task is nearly impossible. The decimal system and the concept of zero, refined and transmitted by scholars like al-Haytham, gave us the agile numerical vocabulary that powers everything from computer code to economic models. The very word algorithm guiding the digital world's every function echoes his name across 1,000 years. This history delivers a crucial message for our own time. Groundbreaking knowledge rarely springs from a single, isolated culture. It is a cosmopolitan project, a collaborative tapestry woven from countless threads gathered across continents and faiths. The most fertile ground for discovery has always been the bustling crossroads, the place where different ways of seeing the world can meet, argue, and merge. Recognizing this shared lineage does more than correct the historical record. It invites us to build a future where the free flow of ideas continues to be our greatest source of innovation and understanding. The true legacy of this centuries-long exchange is not a list of facts, but a fundamental shift in how we see history itself. This was never a simple story of East versus West, but a complex tapestry woven from countless threads of curiosity and collaboration. The great centers of Baghdad and Toledo were not isolated fortresses of thought, but bustling hubs on a global network of ideas, where the work of translating a single text could unite scholars from three faiths in a shared pursuit of understanding. We have watched as the rigorous logic of Aristotle, saved and refined by Islamic philosophers, traveled westward to challenge and ultimately strengthen the foundations of European theology through the grand synthesis of Thomas Aquinas. We have traced the path of a medical textbook from the pen of Avicenna to the lecture halls of Paris, where it guided physicians for over 600 years. This history dismantles the myth of civilizational isolation. It reveals that our modern world, with its scientific language, its hospitals, and its universities, stands on a foundation built by many hands across many cultures. The next time you glance at a digital clock, remember the algorithm that powers it, a concept born in a Persian scholar's book on algebra. The next time you visit a doctor, recall the clinical methods championed in the hospitals of medieval Cairo. This shared past invites us to look for the hidden connections all around us, to recognize that human progress has always been a collaborative project. I would love to hear which part of this incredible story resonated most with you. Was it the astronomical precision of al-Battani, the medical genius of al-Razi, or the philosophical bridge built by Averroes and Aquinas? Share your thoughts in the comments, and let's continue this conversation about our wonderfully interconnected world.